before we'll jump into this topic, let's have a quick recap of what we have learned in our last session. In last session, we looked at these two different architectures, synchronous and asynchronous, or whether we call it sync and async, where we have seen the synchronous is a blocking architecture where one operation or one request it depend on the previous request which already been sent for it to get complete and to get an acknowledgement back, and then you can proceed ahead with the next process or next request itself. So we have seen this, we have seen some of the example, and we have also seen that strong consistency is important here. There will be a little bit high latency, and it will be a single threaded operation, and it is also easy to code. We have also seen asynchronous. It is a non-blocking architecture, and where the one process is not dependent on the other, and it can run simultaneously. We can use multi-threading. It will be low latency, but eventual and weak consistency will be there in this kind of architecture. And we've also seen these examples that how the request goes from web server to primary database and then to the multiple replicas. So this is what the synchronous and asynchronous that we have seen. Let me go back to the topic for today. So this is stateless and stateful architecture. So before we'll jump into details of this, let's understand what exactly is state. I was looking for a definition according to some online uh, information on this particular word, state itself. And as per book definition, the state of any application or anything else in the sense any component in the system. Maybe it is user, maybe it is server, maybe it is database. The state itself is a condition or quality of being at given moment of time. That means at one particular time, if you try to access a database, the database will have certain data. So that will be its state until unless you modify something or until unless you any kind of modification, you update, you remove, you uh, do any other operation on that, the state is not going to change. So that is what the state itself. I'm just giving an example of database, but it may be for anything. So maybe the glass in front of me has water full, so that is its state. If I drink the water and the glass become maybe half full, then that will be the state at that particular time. So state is just a kind of the condition of that particular item at that particular time. Okay. And whether something is stateful and stateless is depend on that how much means how long the state of interaction is being recorded. Again, as I mentioned, till the time data is not updated, the state of data is as it is. Whatever data is there, it's there. Whatever state of that data, it's there. So that will be I'll say state of that particular data or database or data within it. So, and that information means how also we store that information that is also depend on the state. But just to give you a broader line, that state is a kind of condition, as I mentioned in here, the quality of being at a given moment of time. All right. So now we know the what is exactly state. Then the question is what is stateful and stateless. So let's look at stateful. Once we know both of these things, then we'll understand, okay, what exactly its meaning and what exactly we can do with it when we design a system. So stateful is here we are talking about a server example, but it may applicable to any other components as well. But right now, a stateful server remembers client data, that is what is client state, from one request to the next. Now, what does it mean? Just I'm trying to give an example. Just imagine that you are visiting Amazon.com and you go to it and you logged in to it. You will put your login and password, and then you get into the web page itself, and then you start exploring different pages. Maybe you explore multiple products, multiple categories. Maybe you go and visit your account. Maybe you go and visit your orders or maybe your profile. So all these things you do, but you have done login only once. right? And when you're jumping from one page to completely different page, it is not going to ask you login again and again, right? That information is there with the application itself. Okay, that is not going to change. Like if the page is completely different, it is not going to ask you to log in again because it remembers, it already knows that you have logged in and what is the information. The idea or the process behind it's a different part. I'm just giving a very simpler example. I'm trying to explain with simplicity that it remembers what exactly is your login information and what is the password and who you are, what kind of user you are, or maybe there is user ID or something involved in it. So here also what we are seeing, there are three users, user A, user B, and user C. They all are sending requests, similar kind of requests to backend servers. And what server is doing here is they each server, like for user A, user server one is storing the session data. What is session data? Is the interaction of user with the website. I'm just giving an example of website, but just like Amazon.com, when you are interacting with that after you logged in with that website, trying to explore multiple things. So that is a session data. So that session data, suppose it is stored in server one, and I have just mentioned maybe profile image also stored with server one of user A. And similarly for user B, everything is stored in server two. User C, the session data and profile image is stored with server three. So in this case, suppose if user A, see here I have mentioned the steps, I'm explaining the same steps, but I'm trying to explain in my own language. So as user A data and profile and all other information, it's is stored in server one. And if that request, if we send it to server two, it will not be available, right? So the servers two will not able to serve or will not able to remember what is user A was doing with the website. It will not remember what pages that user visited, what product it explored. It will not be because that information, that session data is stored with server one. Even if it goes to server three doesn't have that information. Okay, so what will happen? It will fail if we try to go to any pages that are visited. Like when we press back button in our web page, we go to the back information, like back page, which we have visited previously. So that kind of session data is not available with other servers for user A, and that because that information is stored with server one. Because of that, it will fail to give you that information. Because if the request goes to server 2, but the session data is stored with server 1, then server 2 will not have that information. That request will not be fulfilled. So it will fail. Similarly, for user B, if request go to server 1 or server 3, it will again fail. And similar to for user C, if request goes to server 1 and server 2, it will fail because the data is stored in the respective server only. Okay. So in this case, we can say that user A has stateful uh, architecture behind server one because server one knows what user A data is or session data is. Okay, so it is stateful because it knows what is the client state, what is the user A states. So that's why it is stick to this server one at this point of time. But if it goes to some other server, it is not available. So it will fail. So see, in this case, that means user A has to go to server one, user B has to go to server two, user C has to stick to server three. This is possible. We have seen load balancer in which when we send a request to load balancer, it will be sent to multiple backend servers that we have seen. And it will keep on checking, okay, which server is working, which server is not working. So that we have seen that load balancer is taking care of sending the request to the proper server. So there is something called sticky sessions also can be done. What does it mean? That load balancer, according to user, will send that request to one particular server. Suppose right now user A is there and user A is storing the information, the session data. User A's information is stored in server one. So we can create that sticky sessions or stickiness in load balance itself, that whenever it will receive request from user A, it will automatically route that request to server 1 only. So that is called sticky session. Here I mentioned sticky session. So that sticky session is possible through load balancer. It can keep on sending the user A's request to server 1, user B request to server 2. But then there are some kind of overheads, like you have to keep that server till the time the interaction is not done, till the time the session is not done. So in this case, maybe then adding and removing server will be more difficult, because if you add more server, then and the sticky sessions are there and all the session data is stored in whatever number of servers, the other new servers will have to wait for the new session from new user. Then only it can able to serve it. Or if you remove any of the servers, that session data may be lost. That is also a challenge, because it has to stick to one particular server. And what about the failure itself? Suppose out of these three servers, server 2 is gone down because of some reason. Because of some reason, if the server 2 goes down, then there is a possibility that the server, user B will not be able to serve, will not able to remember what pages he or she explored. So these are the things where one thing you need to remember, that we are remembering the state of user's interaction or user session by keeping it into one particular server. So this is called stateful. The web servers are stateful, not users. Right now we are saying that web server, server 1, server 2, server 3 are stateful because they know the user session data. They remember the user's interaction. All right. This is what is stateful. Now, when we'll move to stateless, then we'll have better clarity. Stateless is the server keeps no state information of user. Means server doesn't know what user interaction was. Server don't have to care about it. What we are doing here is all the requests from user A, B, C will go to web server, but web server will not store this information. This information will get stored in a shared storage. Storage, we'll talk about it, maybe a database where this information will be stored. And whenever we have to get this information, like if user want to explore the different page, or maybe user have to go back to the previous page, that information, that request will send to web server, and web server will pick that information from the storage and it will give it back to user. So here the web server doesn't remember what user A was doing, what user B was doing. User web server is just serving, like looking at the storage and getting the right information and passing back to user. So here we are just decoupling the session from web server to storage. This is called stateless. There are advantage and disadvantage both for both stateful and stateless. It depends on architecture, what kind of architecture that you want to support. It again, as I mentioned earlier, that it again depends on latency, availability, and all other principles that we have to keep in mind when we will think of stateful and stateless uh, architecture or feature. Okay. Here, as I mentioned, and I have mentioned the steps here, all the requests will go to web server. Web server will fetch that information from share storage, and then share storage will give that information according to what kind of user, like who is the user, whether it is user A, B, and C, and that information will pass back to from web server to user. Okay, and see here, just point number 3 is mentioned. The stateless system is simpler, more robust, and scalable, because here we can add more server, we can add more storage, and they can scale independently. And it is easy. Like you don't have to, web server don't have to worry about uh, what was the user session. Your web server will directly just query to the database, and database will give you back the related information. And if there are more and more sessions are coming, more and more users are coming, we can scale, we can add more web servers, we can add more databases that can be scaled separately, right? Mostly people are looking for stateless kind of architecture, so that it will be, as I mentioned, it will be more easy But there are cases where we have to use stateful architecture as well. And here in this, I already mentioned, but the database can be a SQL database, just like relational database, SQL Server or MySQL, or we can use cache itself, where cache database like Memcache or Redis we can use, or NoSQL database. Any of them. Mostly NoSQL database is good choice because they can scale rapidly, they can respond quickly, and because of the same reason, most of the time NoSQL database is being used. So this is what the stateful and stateless. Again, I'm mentioning when you design a system, it depends on the kind of situation, the kind of requirement on the system itself. You have to choose between stateful and stateless. You have to look at that, okay, what kind of request that you're getting, what will be the scale of the request, how many users, concurrent users are there, is it necessary to store in a separate shared storage? But most of the time, the architecture will be stateless. So because it is simpler, scalable, and fault tolerance also. All right. I hope this two concepts are clear for you. Do you have any questions? No? All right, then I'll stop here then.